In this video, we're going to look at inverse proportion, okay? And let's just clarify what inverse proportion is. So in inverse proportion, when one value increases, the other one decreases at the same rate, okay? So let's have a look at an example. If it takes one worker 8 hours to complete a certain job, if I have 2 workers, it's going to take 4 hours, okay? Because if I have more hands, then it will take less time, okay? And if I have 4 workers, it's going to take 2 hours. So if one value is multiplied by 2, the other value is divided by 2, okay? And when one value is multiplied by 4, the other one is divided by 4, okay? So this is what we mean when we say that when one value increases, the other one decreases at the same rate. Again, in this video, we're going to look at some more complex examples and a more advanced method of working out those type of problems. We're going to use this type of statement, okay? Y is inversely proportional to x. Okay, if we want to use the constant k, it's going to look like this. Y equals k over x. And we read this that y is inversely proportional to x. Now, when it comes to the graph of inverse proportion, you can see that it's like a curve. Okay, so let's have a look at some common statements. Y is inversely proportional to x. This is what we just looked at. That's y equals k over x. Y is inversely proportional to the square of x. Y equals k over x squared. Y is inversely proportional to the cube of x. That's y equals k over x cubed. And y is inversely proportional to the square root of x. Y equals k over square root of x. Okay, now let's have a look at some examples of problems. In the following table, A is inversely proportional to B. So I'm going to write this statement, okay? A is inversely proportional to B. And we want to find the equation connecting A and B and then complete the table. So I've got one full pair of values. I'm going to use this pair to work out the value of k. Now, the value of A is 5. The value of B is 10. To find k, I need to multiply the two values and I get 50. Okay, so A equals 50 over B. This is the formula. Now I can use this formula to find the missing values. So here I've got the value of A, so that's 8 equals 50 over B. Okay, now to find the value of B, I need to divide 50 by 8, and that is 6.25. Okay, 6.25. Now to find this missing value, I know that the value of B is 4. So A equals 50 over 4. So A equals 12.5. 12.5. That's it. Let's have a look at another example, which is a word problem. Okay, in an electrical circuit, the resistance R is inversely proportional to the square of the current. When the resistance is 4, the current flowing is 6. Okay, so the resistance is inversely proportional to the square of the current. Okay, again, don't forget about the square. Okay, so the resistance is inversely proportional to the square of the current. Okay, so when you solve whether it's a direct proportional problem or inverse proportional problem, there are two things that you need to read very carefully. First, whether it's a direct proportion or inverse proportion, and then two, is whether it's just proportional to the value or to the square of the value or the square root of the value, etc. Okay, it's very, very important. Then I've got this information here. The resistance is 4, so this is R. Okay, and then the current flowing is 6, so this is I. Okay, so I'm going to substitute those values into my equation to find the formula, okay, or the equation connecting R and I. So R is 4 and I is 6. Now please notice that the value of I is squared. Okay, so that is 4 equals K over 36. Now to find the value of K, we need to multiply 4 and 36, and the value of K is 144. Okay, so the formula is R equals 144 over I squared. So this is the formula. Now we can use this formula to find some missing values. First, find the resistance when the current is 7 amps. Okay, this is the formula. Okay, now I've got the current, so this is I. Okay, so I'm going to substitute it into the formula. Remember that it needs to be squared. Okay, so R equals 144 over 49. Notice that the answer needs to be given to 3 significant figures. So when I put this into a calculator, I get 2.93877 and so on. So 3 significant figures, 2 is the first significant figure, then 9 is the second, 3 is the third significant figure. So I need to look at 8 because it's more than 5. I need to round 3 up. So the answer is 2.94. In the other example, in the other question, I need to find the current when the resistance is 3. Okay, so this is R. Okay, so the resistance is 3, and I need to find the current. Okay, so now to find the current, I need to divide 144 by 3. So I squared equals 48. To find the value of I need to square root 48, and that is 6.9282 and so on. And again, the answer needs to be given to 3 significant figures. So 6 is the first significant figure, 9 is the second significant figure, 2 is the third significant figure. Okay, so I need to look at the next digit, which is 8, and again, because it's more than 5, I need to round 2 up. So that is 6.93, and that's the final answer.